Good morning, folks. I want to just talk to you very briefly about the use of the UO2 Ultra Oxygen Viper 30 in our sump tanks. These are our sump tanks in commercial systems, and we have taken to using the Viper 30 as an atomizing unit. I hope you can hear me with the noise in the background. Right, so I want to just chat through what we're doing here in principle. We've got a submersible pump in here, which is running on a float valve, so a float switch. In other words, if the water level drops in this sump below a critical point, the pump would protect itself, it would turn off. This is the sump where the water is returning from fish tanks. It's returning, and it's our raw water. It's the unconverted water that has the fish wastes in it in the form of solids and in the form of ammonia. Comes in here, and we've got an anti-clockwise movement as a result of the flow and the way the water falls in. But by having an anti-clockwise movement, we've created fast-moving water on the outside and an eddy in the middle. So all the solids will gravitate to the middle, where this pump will pick it up. So the soft solids that are coming from fish come in, they go to the Viper pump, they get picked up, and then they get pushed through the Viper 30, which does two very important things. Firstly is that it increases, it injects ultrafine oxygen and ambient air at a very small amount, and this valve is the concentration. Now if you look at the little bubbles that are coming out of this outlet, if I open this valve, you'll see the bubbles increase in size. There you go. Okay. The bigger the bubbles are, the less stable those bubbles are, and the more they rise and will basically become air again. There is obviously a very large amount of aeration that's happening as a result of that, what I'm doing now. But our objective is, and this is the point of this video, when we run the Viper, we want to adjust this valve down so that we are creating ultrafine bubbles. So we might not want to see large bubbles coming out there. We want to see a fine spray of bubbles, because what that'll do, it'll create a very strong vacuum over here on this pipe, which will force the bubbles that are moving through this Venturi, through this Viper, which is amazing technology, by the way. When it goes through here, the size of the bubble becomes much, much smaller. So that's the first objective, is to inject oxygen in an ultrafine bubble, which is then stable and increases the water, oxygen and ambient air content. So in other words, we're injecting potentially 8 liters of air a minute into this tank, which fluffs up the water. It actually becomes lighter, and the oxygen content, air content is very high, which is what we need in a tank where we've got potentially high levels of solids. Now, the main advantage of this unit is obviously the oxygen, but with that, and an unintended consequence, which is just absolutely amazing for our aquaponics units, is that while these soft solids move through here, they become atomized. They get broken up into very fine particles. And as they get broken up, they then come out the other end in a much smaller format, and they are then more available to the microbes further down the line, the bioremediation and bioconversion processes, which you will all know from the training course. They are very detailed, very specific, and they have a process flow. You have to follow a very specific sequence in order to get that conversion to be optimal. But by atomizing those solids in the beginning, and then allowing this pump to transfer that water to the aquaponics unit, we have got the perfect mix. And we then run through our oxidizing solids bioreactors, where we allow separation of solids. Heavy solids will settle and suspended solids will move through for bioconversion. So we all know about that. For those of you that have been on our courses, that is one of the main features of our design and our approach, which is different to a lot of other people. And then this technology adds a dimension which really makes the efficiency of our nutrient conversion, it elevates it. In fact, we're busy with trials at the moment where we're reducing the number of fish in our systems because of the effectiveness, the efficiency of the atomization and how that helps us in the bigger picture and the bigger scheme of things. So just wanted to run that through with you guys as an informational in terms of the research that we're doing and where we're going with oxygen management and nutrient conversion, solids breakdown, and just general efficiency in the system. So I hope you guys have a great day. Let us know your comments.